Thank you very much for the kind introduction. And yeah, you've already heard the title. It's going to be about chlorine. So, and we wanted to find new detection methods for the retrospective verification of exposure. And this research was carried out in the Spitz laboratory and with a collaboration of the University of Fribourg and also another institute, the Functional Genomics Center located in Zurich. So to start with, well, why is there a need for chlorine biomarkers? So this whole work was actually initiated by the chlorine uses in Syria, where chlorine has been used as a chemical weapon. And of many of these attacks, it seemed that around 90% were attributed to the chemical chlorine. And chlorine as a chemical weapon, well, it caused a lot of deaths among the civilian population in Syria. And the use of chlorine as a chemical weapon, or the use of a chemical weapon as is prohibited by the Chemical Weapons Convention. And so in the case of chlorine, it's very hard to trace it back so that it has been used, because chlorine, as you can see at room temperature, it's a gas and it evaporates quickly. And in the environment, it leaves behind just very few markers. For example, in wood, there is a biomarker called bornyl chloride. However, also this compound here is not chlorine specific. And in this work, we wanted to find a biomarker which can be found in the human body. So one can verify the use of chlorine, and so then that one can convict the perpetrators of the Chemical Weapons Convention. And our approach was to develop a straightforward analytical method, including minimal sample preparation steps. And as a third task or goal, we wanted to find a possible stable biomarker, because for a biomarker to be useful, it needs a high stability, because you can imagine that if you have an analytical sample from a war zone, for example, it takes a lot of time until this sample can be analyzed in a laboratory. And that's why stability is actually a key factor. And so that's why we went for the human hair as our matrix. And so we took human hair and we exposed it actually to a whole set of chlorinating agents, because we all know there are various ways to introduce a chlorine atom into an organic molecule. And then we took our exposed hair samples and went for a complete hydrolysis and derivatization. That means we were cutting down the protein keratin, which is actually the main component of hair, and we were cutting it down to the level of individual amino acids. And these derivatized amino acids were then analyzed by liquid chromatography coupled with a mass spectrometry. And in the first stage, we went for a targeted analysis, meaning that we were looking for specific adducts, which we expected to be present in these samples. And later on, we also wanted to know if it's possible to perform an untargeted analysis, meaning to find differences between an exposed and an unexposed sample, which are probably not obvious And so that's why here we made also a, let's say, computational approach. And now I'd like to give you a little bit more information of the experiment. So yeah, here you can see.
Sorry for interrupt you, but we cannot hear you anymore. Maybe it's a problem here or at your microphone. We do not know yet. Maybe you can check first if you can turn a little bit louder your one.
Let's see, can you hear me now?
Is it okay? It works again. Super, thank you. Please
Great.
go one slide back. So fascinating, nice slides, but we missed the point due to acoustics.
Okay, so here. So you missed the whole slide, or sorry? Or
no, only the final part.
Okay, so thank you. Okay. So the final part means that we made the analysis by liquid chromatography coupled with mass spectrometry, and we went for a targeted analysis where we looked for specific adducts, but also a untargeted analysis in the case of a principal component analysis. So that means a computational approach. Okay, now back to chemistry or the chemicals. Here you can see the set of chlorinating agents. So for sure, we used chlorine gas, but also hydrogen chloride, in this case, in its gas state. And then, of course, also bleach and household bleach, because we expected that maybe these molecules, they could form similar adducts. And then also some chemicals that are very important in the chemical industry if you want to perform a chlorination. And these are oxyl chloride, thionyl chloride, and also sulfuryl chloride. Then we also used phosgene. Phosgene has also been used as a chemical weapon, mainly in the First World War. And the same applies for chloropicrine. It's also a chemical which has been used as a chemical weapon. Okay, and now the exposure experiments. It was very difficult because some of these molecules are gases at room temperature, some are liquids, and so we needed to design these experiments in a way that we performed the exposure experiments with gases. So we just let the hair in a specific atmosphere for 10 minutes at room temperature. And for the liquid exposure experiments, we wanted to make sure that there is no contact between the hair sample and the liquid chemical. That's why we used a glass vessel, and so the exposure was only via the gas phase. So there was no contact between the hair sample and the liquid chemical. On the right-hand side, you can also see the exposure experiments with bleach and household bleach. In this case, we need to immerse our hair samples in a solution with a specific concentration of these chemicals. Okay, now a little bit more information on the method. As I said, we performed our exposure experiments, and then we went for our hydrolysis. We carried it out with hydrobromic acid at 110 degrees for 24 hours. And under these harsh conditions, the keratin is cut down into individual amino acids. And these amino acids have then been derivatized. We used AQC as a derivatization agent to functionalize the amino part of our amino acids. And then we analyze them with reverse phase chromatography on a Waters UPLC. And now some results. In our targeted approach, we were looking at tyrosine. Tyrosine is the amino acid here with our phenolic group here. And at this point, we could see that tyrosine reacts to 3-chlorotyrosine on the left-hand side and 3,5-dichlorotyrosine on the right-hand side. And these graphs below show that we could find these chemicals in significant amounts in the samples of chlorine, sodium hypochlorite, and sulfur chloride. So it seems that these chemicals were all forming the same adducts, which is important if you think about the chemical weapon. At this point, it seems that chlorotyrosines are not specific for chlorine, but only specific for these 3 chlorinating agents. And as I said in the introduction, this the verification is also very important, and we verified the presence of these chemicals by using reference material, and so we had a good overlap, and we carried out this step for all compounds in our targeted analysis. Yes, and now the stability, as I said, stability is also a key feature of a biomarker to be useful. And that's why after our exposure experiments, we took our hair samples and stored them at room temperature for a certain period of time. And this here in the first, you can see T0 indicates was our starting point. And then 2.5 months later, we analyzed the same hair samples and we could still detect the 3 chlorotyrosines. And it was also the case 10 months post-exposure. So it seemed that once this chlorotyrosine is formed, it remains stable in our hair, in the human hair matrix. This was actually the same case for the 3,5-dichlorotyrosine. We could still detect it 10 months post-exposure, which is a very important finding. In our targeted analysis, we were also looking for other amino acids because we were also looking at the sulfur-containing amino acids. In this case, we were looking at cysteine and also cysteine, so the dimeric form of cysteine, and those are also main components in the human hair. And at this point, we were looking at oxidations. They might not be that specific, and it was actually the case that there was a rather high background level. And from literature, we already know that this oxidation can have many reasons. It's also possible to induce this reaction in an atmosphere with oxygen and UV light, which is present actually at all times. So that seemed that cystic acid, yes, we have a positive result for the household bleach, but in this case, the bleach concentration is very high. And so here the oxidation was actually expected. Then we continued with sulfur-containing amino acids. So for example, here the methionine, methionine can react to methionine sulfoxide and the sulfone on the right-hand side. And also here, we had a high background level for both of these chemicals. And it did not seem that these are useful biomarkers. However, at some points, you could see that with these chemicals, as this oxidation is actually promoted, especially in the case of methionine sulfoxide. Okay, and now I would like to move to the other part. It is the untargeted approach. And here, the workflow was like that we took our raw data, our LC-MS data, and first we performed a peak picking algorithm. And after that, we had a very important step, which we called SDA, the shrinkage discriminant analysis. because at this point here, we realized that our samples, they were highly correlative. So meaning that around 99% and above 99%, these samples had the same peaks. And so it is very important that we were shrinking down the whole problem, because otherwise we would have over parametrization. And so that you were just comparing noise with other noise from other samples. And so after this key step, where we had our corrected data, we then performed the principal component analysis. And the principal component analysis should then tell us the differences between these exposure experiments, so between these chemicals. And we could see that here in the first 2 dimensions of our principal component analysis, that this middle section here, that sodium hypochlorite and household bleach, but also hydrogen chloride and the untreated, they could hardly be separated from each other. So there was a high correlative thing going on. But in the case of chlorine, you can see that this section here can be greatly separated from this middle section, meaning that here in these samples, there were some molecules present that make a difference. And if we are now going back into the raw data and check what these differences are, we could find that it was actually the chlorotyrosines that make this difference here. And then another finding was that you can see this yellowish cloud on the left-hand side. We had sulfur chloride and chloropicrin. They also seem to form an adduct that can separate and differentiate between this middle section. And it was the same case for phosgene, oxyl chloride, and phenyl chloride, forming this right-hand green section. And now we were interested in what makes these differences. And so we were looking to identify these differentiating features. As I said, here on the left-hand side, we had these 2 chemicals forming an adduct, where from now, we only have a mass. And this mass was found in these samples with 415 m/z. And on the right-hand side, we had these 3 chemicals forming an adduct with 337 m/z. And now we have more research going on, because now we would like to identify these compounds. And this is envisaged to be done with high resolution MS, so to get a chemical formula to maybe identify the molecules behind these 2 masses. Okay, as a conclusion, we can say that chlorotyrosines, they were found in several chlorinating agent exposure experiments. And most important, they were found up to 10 months post-exposure. We could also say that the oxidations of cysteine methionine were not considered to be suitable biomarkers. As I said, there was a high background level for these chemicals. And our untargeted approach in the end showed that, well, the chlorotyrosines were the main discerning features, which was actually very important to know that we were on the right track. And then also that a further differentiation would be possible. However, now there will be more research needed. And furthermore, it seems that there is no unequivocal discerning feature that one can identify chlorine as the source of, let's say, the formation of chlorotyrosines. Okay, and that brings me to the last slide, where I would like to thank you for the invitation and your kind attention. So thank you very much.